The building blocks of matter. Atoms. Matter. Anything that has mass and takes up space, volume. Examples. A brick has mass and takes up space. A desk has mass and takes up space. A pencil has mass and takes up space. Air has mass and takes up space. All of the above examples are considered matter because they have mass and take up space. Can you think of anything that would not be considered matter? Atoms. Smallest possible unit into which matter can be divided, while still maintaining its properties. Made up of protons, neutrons, electrons. The solar system is commonly used as an analogy to describe the structure of an atom. For example, what is the smallest possible unit into which a long essay can be divided and still have some meaning? Atoms are so small that it would take a stack of about 50,000 aluminum atoms to equal the thickness of a sheet of aluminum foil from your kitchen. If you could enlarge a penny until it was as wide as the US, each of its atoms would be only about 3 centimeters in diameter, about the size of a ping-pong ball. A human hair is about 1 million carbon atoms wide. A typical human cell contains roughly 1 trillion atoms. A speck of dust might contain 3x1012, 3 trillion, atoms. It would take you around 500 years to count the number of atoms in a grain of salt. Let's experiment. In order to try to gain an idea of how small an atom really is, you will complete the following activity. Cut a strip of 11 inches paper in half. Discard 1/2. Cut the remaining piece in half. Continue cutting and discarding the strips as many times as you can. Make all cuts parallel to the first one. When the width gets longer than the length, you may cut off the excess, but that does not count as a cut. Results. How many cuts were you able to make? Do you think you could keep cutting the paper forever? Why or why not? You would have to cut the paper in half around 31 times to get to the size of any atom. Protons, positively charged particles, help make up the nucleus of the atom. Help identify the atom, could be considered an atom's DNA. Equal to the atomic number of the atom. Contribute to the atomic mass. Equal to the number of electrons, neutrons. Neutral particles, have no electric charge. Help make up the nucleus of the atom. Contribute to the atomic mass, electrons. Negatively charged particles. Found outside the nucleus of the atom, in the electron orbits/levels, each orbit/level can hold a maximum number of electrons, first equals 2, second equals 8, third equals 8 or 18, etc. Move so rapidly around the nucleus that they create an electron cloud. Mass is insignificant when compared to protons and neutrons. Equal to the number of protons involved in the formation of chemical bonds. Hydrogen, H, atom. Plus. Notice the 1 electron in the first orbital. How many more electrons can fit in the first orbital/level? Even though there are no neutrons present, hydrogen is still considered an atom. Oxygen, atom. Notice the 2 electrons in the first orbital/level and the 6 in the second. How many more electrons can fit in the second orbital/level? Sodium, Na, atom. Notice the 2 electrons in the first orbital/level, 8 in the second, and 1 in the third. How many more electrons can fit in the third orbital/level? The atom's center. Protons and neutrons are grouped together to form the center or nucleus of an atom. Quarks. Particles that make up protons and neutrons. Notice the smaller particles that make up this neutron after you take a closer look. Plus. Notice the smaller particles that make up this proton after you take a closer look. What do you notice about the number, subatomic particles? Weight comparison. Protons, neutrons, electrons. Neutron equals 1.674928 x 10-27 kg. Proton equals 1.67262331 x 10-27 kg. Electron equals 9.10938997 x 1031 kg. 1839 electrons equals 1 neutron. 1836 electrons equals 1 proton. How do you think the mass of a neutron compares to that of a proton? 1 neutron 1 proton. Subatomic particles. Size comparison. Protons, neutrons, electrons, and quarks. Atomic number. The number of protons in the nucleus of an atom. What would be the atomic number of this atom? Mass number. The total number of protons and neutrons in an atom's nucleus. Expressed in atomic mass units, AMU. Each proton or neutron has a mass of 1 AMU. What would be the mass number of this atom? Plus 3, 4. 3 protons plus 4 neutrons equals a mass number of 7 AMU. Why did we not account for the electrons when calculating the mass number? Building atoms. Using the whiteboard and the proton, neutron, and electron pieces, build the following atoms, and determine their atomic and mass numbers. J0296981. AG00266_. Forces in the atom. Gravitational force. Electromagnetic force. Strong force. Weak force. Gravitational force. The force of attraction of objects due to their masses. The amount of gravity between objects depends on their masses and the distance between them. J0174012. J0219080. Electromagnetic force. The force that results from the repulsion of like charges and the attraction of opposites. The force that holds the electrons around the nucleus. Plus. Strong force. The force that holds the atomic nucleus together. The force that counteracts the electromagnetic force. Weak force. This force plays a key role in the possible change of subatomic particles. For example, a neutron can change into a proton, plus, and an electron. The force responsible for radioactive decay. Radioactive decay process in which the nucleus of a radioactive, unstable, atom releases nuclear radiation. Plus. Notice how the original particle changes to something new. If you need help remembering weak force, just think of isotopes. Atoms that have the same number of protons, but have different numbers of neutrons. Examples: hydrogen, protium; hydrogen, deuterium; hydrogen, tritium. Notice that each of these atoms have one proton, therefore they are all types of hydrogen. Atomic mass. The weighted average of the masses of all the naturally occurring isotopes of an element. The average considers the percent abundance of each isotope in nature. Found on the periodic table of elements. Example: hydrogen, Protium. Mass number equals 1 AMU. Hydrogen, deuterium. Mass number equals 2 AMU. Hydrogen, tritium. Mass number equals 3 AMU. What would be the atomic mass of hydrogen if these three isotopes were found in the following percentages: 99.9, 0.015, 0, respectively? If you simply average the 3, 2 AMU, 1 AMU plus 2 AMU plus 3 AMU/3, would be the atomic mass, but since 99.9% of the hydrogen is protium, the atomic mass is around 1 AMU, 0.999 x 1 AMU. Ion. Charged particle that typically results from a loss or gain of electrons. Two types. Anion equals negatively charged particle. Cation equals positively charged particle. Currently, this atom of oxygen is neutral because it has an equal number of electrons, 8, and protons, 8. Symbol equals O. 9. Now that this atom of oxygen just gained an electron, it is no longer neutral or an atom. It is now considered an ion, anion. This ion has more electrons,